Hello everyone. Today we are going to talk about the third section of the chapter confidence intervals for one population mean. This section is the margin of error. Okay, let's move on. We know that we can use confidence interval to estimate the population mean, since calculating the exact population mean is very difficult. Also, we know that there is always a sampling error in this case. So in this lesson, we are going to determine how the sample size affects the accuracy of an estimate. Let's begin with introducing the concept of the margin of error. The margin of error for the estimate of mu can be calculated by this formula. Okay? E equals z alpha over 2 sigma divided by the square root of n. In this figure, E denotes the margin of error and x bar is the sample mean. So margin of error is either sides of x bar. As you can see, the margin of error goes to left side as well as to right side. Okay, the value on the left side of x bar is the lower bound of the CI. It's this. So the margin of error is equal to that. Before that, the value on the right hand side is the upper bound of the confidence interval. Okay, the value on the left hand side, that is the lower bound of the confidence interval, and the value of the right hand side, that is the upper bound of the confidence interval. Okay, so the margin of error is equal to half the length of the confidence interval. The length of this confidence interval is 2e. So the margin of error is equal to half of the length of the confidence interval. Okay. All right. Now let's move into an example. This table has data on ages of 50 people. Using this table, let's find 95% confidence interval for mu. Okay, so now our alpha is 0.05. Then the z-score of alpha over 2 is 1.96. Okay, z-score of alpha over 2 is, that is z-score of 0.025, that is 1.96. And our n is 50, the standard deviation is 12.1, and the x bar is 36.4 as we calculated before. We can just plug these values to the formula, this one, to find the lower bound and the upper bound and to compute the confidence intervals. When we simplify this further by plugging those values, we will get 95% confidence interval from 33.0 to 39.8. Okay, all right. There is one important observation that you can make from the confidence interval we have obtained. As you can see, this interval has a wide range of the possible values of mu, from 33 to 39.8. It has a wide range. When we get wide range for a confidence interval, its precision is poor. The precision of it is poor when we have a wide range for the confidence interval. Now look at this diagram. To interpret margin of error, 36.4 is the sample mean of our example, and we have calculated the lower bounds and the upper bounds of the confidence interval using these two formulas. By simplifying them, we got 33.0 and 39.8, right? The sample mean minus 3.4, we get 33.0. The sample mean plus 3.4, we get 39.8. That's how we got these two, this lower bound and the upper bound. We can say that 3.4 is the margin of error, and it's to either side of mu. either side of sample mean x bar, to the left side and to the right side. If you go to the left side from the sample mean, you will get the lower bound. If you go to the right side from the sample mean, you will get the upper bound. And as I said in this example, margin of error can be calculated by C alpha over 2 times sigma divided by square root of n in this formula. In our case, it's 3.4. The margin of error is 3.4. Okay. Now we observed that in the previous example, its confidence interval was with a poor precision because of the wide range of it. This precision is determined by the margin of error, which goes to left as well as to right from x bar. Okay, and one important key fact is that for a fixed confidence level, increasing the sample size improves the precision. Okay, increasing the sample size improves the precision. On the other hand, when we decrease the sample size, it results in a poor precision. If we increase the sample size, it increases the precision, and if we decrease the sample size, it results in a poor precision. Okay. Now let's see how to calculate the sample size for a given margin of error. Okay. This formula in this box is basically derived from the first formula that we learned at the beginning of this lesson for the calculation of margin of error. We got this formula from that formula. Okay, we just have to subject n from the formula. We have C alpha over 2, and we have sigma, and we have margin of error E, and the Z alpha over 2 sigma divided by E, the whole thing squared, we will get n. Okay, check. You know that a sample size cannot be a decimal value, right? So we can round up the value to the nearest whole number. Okay, if we get, as an example, if we get 55.6, we will round it up to 56, like that. As I said you earlier, I will repeat again. The sample size can be calculated by dividing C alpha over 2 times sigma by E, and then squaring it out. Okay, all right. Okay, let's move on to another example. This problem is related to the previous example on slide number 3. As you remember, here the problem is to determine the sample size if we want to be 95% confident that mu is within 0.5 years of x bar. That is, mu can be any value in between x bar minus 0.5 and x bar plus 0.5. 0.5 is the margin of error, and recall from the previous example, that's the standard deviation that we used in the previous example. That is the same for this example. That is 12.1. Okay. Alright. Now let's plug these values to the formula to find n. Okay, this is our formula to find n. We know z value, we know sigma, we know E, and we can get the value as 2249.79, and we can round it up to the nearest whole number, which is 2250. Okay, that's how you calculate the sample size for a given value of margin of error. Okay. The next problem is to determine a 95% confidence interval for mu with check in the sample size which we have found just now. The sample size that we found is 2250. You should be very familiar with the calculating the CI using this formula. We just need to plug the values, right? We already did this. We just need to plug the values using the new sample size, and we can see whether the precision is increased or not. Okay, we just need to plug the values to x bar and z alpha over 2 sigma and the square root of n, and then we can get, after simplifying, yes, we can get the confidence interval from 38.3 to 39.3. So with these new values, the confidence interval has become very narrow, right? It's narrower than the confidence interval that we had earlier. We had a wide confidence interval before. Now it's very precise. The confidence interval is very precise. Okay, how can we interpret these results? We can say that the mean age of all people in the civilian labor force is within 38.3 years and 39.3 years. Also, we can be 95% confident about this argument. Okay, I'll repeat you again. We can say that the mean age of all people in the civilian labor force is within 38.3 years to 39.3 years. Also, we can be 95% confident about this argument. Alright, that's all for this section. See you guys in the next section. Thank you.